It's K8BYP in the ham shack on a day where the air outside is absolutely filthy. And there at a couple miles distance is a smokestack. It's really hard to see it, the air's so bad. And a couple of short clips from one of my favorite movies ever, Night Patrol.
How much is coffee?
30 cents.
Okay, a refill.
Refills are free.
Okay, give me a refill and a slice of garlic cake.
Okay.
And?
Move!
Wait, what's your thumb doing on my steak?
Oh, you want to drop it again?
And?
Here's your soup.
What's your thumb doing on my soup?
Here's an infection my thumb. My doctor told me to keep it warm.
Why don't you take and shove that thumb up your ass?
I do that when I'm back in the kitchen.
And now on to a more serious topic. Thinking with the Tektronix Time Domain Reflectometer, TDR. The TDR makes a extremely high rise time pulse from a PIN diode, transfers it to this reading unit out to the transmission line connected to an unknown length of cheap RG58. And my goal here is to match the length of these two 50 ohm cables. It's not rocket science. What we see here, when the delay time is adjusted, time distance, is that the trace moves, do, and that gives a start time on the left. No, correction, start time on the left, and along that length of cable, the ending time here, which is 5 major divisions, 2 minor divisions, and just a hair more, at a setting of x1 and 20 microseconds, and that comes out to be 108 microseconds. A little bit of rocket science, but it's a small rocket. It doesn't fly very far. The interesting things to see here are what we see if we expand the sweep way out and change the time distance and change the zero set to move that start there. And we see an ugly perturbation there in that pulse coming from the sampling head here out to the unterminated end of the cable. That's forward there, that's not showing the reflected. There's that area magnified, and that area is right there. As I unscrew this, watch what happens. Unscrewing. There. Now that junction right there, that coupler and the SMA to PL is open. And when I screw it back on, it goes back. That goes to show a horrible discontinuity in that cheap piece of junk connector. Normally for any decent RF work, we'd use only the same kind of cable, minimum number of connectors, but this goes to show the reflections, the horrible reflections in a typical amateur radio antenna system loaded with connectors and switches that do not show in the SWR meter. SWR meter will not detect that. But that's reflected RF that an ALC can pick up and cut the gain of the transmitter back. And this kind of thing also results in RFI in the ham shack. Notice I'm not playing with toys here. I'm not playing with some piece of crap nano VNA or some rig expert piece of junk. See that? Laboratory grade equipment. Completely, utterly restored. Took me a month. High end. This mainframe, these plugins, and the extended range spectrum analyzer all completely restored. This mainframe and plugins were $50,000 in the late 1980s. Guess what that would be now? I don't think this equipment's available analog. These are results with proof. This is an engineering shop. This is not a button-pushing, wannabe, no-code playing game shop. I prove what I say to you. Important notes on time domain. In time domain, with transmission lines, there are no such things as voltage, current flow, impedance, or frequency. None of those concepts exist in and on that transmission line. That line is not circuits. It is not a circuit. This is not a circuit measurement. By the laws of physics and circuit analysis, a circuit is defined as a closed path through which a current flows from the source through the circuit and back to the source. And I guarantee you that open transmission line is not a circuit. Therefore, the concept of current does not exist. It's not that there aren't moving charges on that line, but they don't constitute current. It's something different. There's no such thing as frequency. A TDR does not have a frequency. It is in a time domain the inverse of frequency. T equals 1 over F. It is a pulse, start here, and a time to propagate to that fault, which is that physical distance. There is no such thing as impedance of that transmission line. Does not exist in the time domain. The line, this, connectors, ports, all have a 50 ohm characteristics. Not nano VNA's crap. Tektronix. See here? 50 ohm. It does not say 50 ohm impedance. Impedance is a construct in circuits. There are no circuits here, therefore impedance does not exist in or on transmission lines. Impedance is a series characteristic of a circuit which impedes the flow of current, and transmission lines do not impede the flow of current. At the worst, the dielectric losses constitute an admittance. 1 over Z equals Y. That is a loss. That's also in the time domain because a loss is with regard to propagation time. The further it propagates, the more loss there is. This cannot be a circuit because the characteristic of the line is defined as a terminating resistive value that results in no reflections. That is not a circuit definition. That can also be approximated by an infinitely long line where there is simply no return. And an infinite line which is unterminated is not terminated by resistance or a resistive value. These are concepts that even engineers, EEs that have graduated, don't understand. Chu up at U Toronto, he's a regular IEEE contributor, says this electromagnetics and transmission lines are the most difficult course for EE students. They don't get it.